in just like 1 minute. All ready, Elham?
Yes.
Excellent. Okay, well, welcome everybody to the International Joint Conference on Biometrics 2024. It's our second day, and we're really pleased to present our next keynote speaker of the week. Let me just get the bio up here. It's Elham Tabassi. She's from the National Institute of Standards and Technology, NIST, of the United States. She is the Chief AI Advisor. And when I say that, it's quite impressive because, as you well know, NIST is highly respected around the world for the work they do in standards and technology. They become a reference for many, many things, especially in biometrics, of course. They're a huge part of our community. So to have that title of Chief AI Advisor, I think is really awesome. And she's been a role model to me over the many, many years that I've known her. So it's going to be great to hear about what they're working on. But we should know that Elham was part of the team that developed something called NFIQ. Everybody raise their hand if they know what NFIQ is. So for those who don't, it stands for NIST Fingerprint Image Quality, which has become a reference standard for measuring fingerprint quality worldwide. She's done many, many things in terms of biometrics. She's a fellow of the Washington Academy of Sciences, a senior member of IEEE on the U.S. government's AI Standards Coordinator, the National AI Resource Task Force, and very cool, I just read this, was named by Time Magazine as one of 100 most influential people in AI. Wow, what a list. Well, so welcome, Elham. She had some personal things and couldn't make it in person, but we're just so pleased to have her presenting today. Thank you.
Oh, thank you, Stephanie, for such a warm welcome. Hello, good morning, everyone. I really, really wanted to be there. I'm honored to give this keynote. I grew up in the biometric community. That's where my research has been within NIST. I learned so much from Stephanie, Nalini. These are all giants in the field that helped me grow and learn and try to be a better researcher. So it's a absolute honor to do the keynote at IJCB. Just like many of you, I was, submitting papers and getting giddy and excited that my paper at IJCB got accepted, or be program reviewer and try to review the paper. So this is really an honor in the career to go back to my basically home and try to give a keynote. And I was so looking forward to be in with my people, but as Stephanie said, life had some other plans for me. We are grateful that everything is fine, but I just couldn't travel. So again, thanks for the invitations. And this is not going to be a very or at all technical talk, but I'll try to give you some of the things we have done in the area, in the space of AI in the past few years, and some opportunities for the works to engage with us, and then finish with some of the closing talks. I think I sent a fancier title, and that's exactly what we're trying to do with artificial intelligence, to bring the community together, to unleash innovations by trying to better understand limits and capability of the technology, provide a safe space for the innovation to happen, and technology get better, so we all, any corner of the world, can benefit from its potentials. Trying to move slides. Right. For some of you that may not know NIST, National Institute of Standards and Technology, a very quick overview that we are a non-regulatory agency under Department of Commerce. NIST was established in 1902, and since its establishment, NIST mission has been to promote U.S. innovations and industrial competitiveness And we do that by advancing measurement science and standards that make technology more reliable, more secure, more private, more interoperable, in other words, more trustworthy. And that's sort of exactly what we're doing in the space of AI. NIST standards and measurement work all along its existence of 120 plus years has helped many emerging technologies earn trust. And Stephanie mentioned the biometrics, and I'm sure you're familiar with a lot of the work and evaluations on face recognition, fingerprint recognition, iris recognition that NIST is running, and I was proud to be a member of those teams. But that earning trust, that cultivating trust in technology becomes more challenge for artificial intelligence. Because as you know, there is a lot of issues, there's a lot of unknowns that make trusting the technology seem challenging and risky. AI systems does not generalize well, they generalize poorly. There is a lack of guarantee about how system behaves. They exhibit biases. They have vulnerabilities. So there are a good number of unknown problems, and I think you all agree that when it comes to the AI and AI models, and particularly these larger models, there is a lot that we want to know that we don't. So bear with that thought for a second. And as the AI start improvements, the deep learning advances in early 2010, 2011, 14, more and more companies, organizations, civil society, entities in government and outside start thinking about frameworks for principal AI governance. And by the way, 2018, while AI is not new to NIST, and many of us has been working in the area of the machine learning, computer vision for a very long time, 2018 when we formally established this program to look at trustworthy, responsible AI, which we are now called NIST AI Innovation Lab. So around 2018, we see a lot of more this type of high-level value-based documents that talk about AI needs to be non-discriminatory, trustworthy. And in fact, there were so many of those that a center at Harvard studied them. There were more than, I think there were about 200 or so, and categorized them into 36 or so different categories. And yet, even with all of these resources, if you are a developer, deployer, you in an organizations and want to deploy AI systems, want to develop AI systems, and want to make sure that they are trustworthy, there wasn't really a clear solutions, recommendations, guidelines on how to make the system safe, transparent, fair, et cetera, et cetera. And this is where AI RMF comes in, directed by a congressional mandate. NIST developed in consultations and bringing the input from the community. The AI RMF, it's a voluntary set of guidelines, recommendations for mapping, measuring, managing, and governing the risk of AI. The point of this slide is not read all of the words. I know it's an eye chart, but just try to tell you that while it is very detailed, at the same time, it's flexible, structured, systematic, and it takes a rights-preserving approach, and it's very sensitive to the actors, to the different context of the use. So what we mean by each of this one, the AI RMF is trying to provide outcomes that needs to be achieved rather than prescribing how to achieve those outcomes. So in that sense, it becomes both detailed and flexible to allow for adapting to the technology as technology improves, but also flexible so that different entities with different resources can use that. In terms of systematic and structured, I will talk a little bit more about this. The first half of AI RMF, again, this comes out at the time that there is a lot of talk about trustworthy, responsible AI without really having a good grasp of what constitutes trust. What do we mean by responsible AI? What are the characteristics of a system so we can judge it to be trustworthy? How do we assure for them? So the first part of that focuses on kind of coming up with a shared understanding of the different terms, provide taxonomies for risks, and basically try to unpack this concepts, as high-level concepts, because that becomes the first step of understanding what to measure. Once we have a good understanding what to measure, when we have a good interoperable language to talk about them, then we can move on to how to measure. That is actually very near and dear to our heart, methods and metrics for measuring AI systems functionality and trustworthiness. I will be talking about them. In the terms of the rights respecting and sensitive to the context, we all know that AI systems are more than just data, compute, and algorithm. There are complex interactions of data, compute, and algorithm with the environment that are being used, with the human that operates it, or human that's being impacted by that. So in the AI RMF, there is a lot of purposeful move towards bringing a interdisciplinary view, looking at the systems beyond just the technical lens, expanding the evaluations beyond just model testing in laboratory setting that can let us know the capability of the models, but also allows us to do stress testing to identify the risks and the edge cases, how the system behaves in the under stress and on edge cases. But also test the systems and understand the systems in their native context of use, so that we can understand and measure the context and impact within the context of the use. So here I have an example of how we go about defining and bringing the community on a shared understanding. I have two definitions here for you to show, just making the point that we leverage the work that the whole world has been doing. So the definition of the AI systems is based on the definition from the OECD. And maybe this is a good time to say that because AI systems are socio-technical and because AI systems are interdisciplinary in development of the AI RMF and a lot of things that we're doing since then, we make sure to engage the community of not only technology developers with critical skills in machine learning, math, stat, computer science, but also the community that study the impact of the technology. That's psychologists, sociologists, philosophers. And let me just tell you that how much I learned by opening up the aperture and talking to the people that from the domains that I basically didn't grow up with. So that highlights the importance of the shared terminology. But the more important point that I want to make in this slide is the definition of risks that is leveraged from the international standard organizations definitions and has been adopted in some of the US government and other governments around the world. The definition of risk here is a composite measure of an event's probability of occurring and the magnitude or degree of the consequences of that event. Or neutral. So what it makes, what's the result of that is that risk management becomes immediately, based on this definition, about maximizing the benefit while minimizing its negative impact. And AI RMF talks a lot about this, that the risk of not using AI is a risk that also needs to be understood. And I think this is a departure from some of the other global, AI governance documents that mostly focus on things that can happen in a wrong way and negative impact. Okay, we also try to be kind of humble in the development of the AI RMF and say that there is a lot of challenges and there is a lot of unknowns, and we are not going to have the responses to that because either the state of the science is not ready or because they are so context dependent that we should leave it to the people that are using the risk manager applying the AI RMF to do that. And many of them are basically stemming from the fact that the development environment and the assumptions that we make during the development or during any technology use are not exactly the same constraints and requirements that happens in the real world. So the real world is really different from the setting that we start designing and developing the systems. So let's just go quickly over them. The first one is that measuring risk is difficult. It's a technical challenge. And even many of you, I'm sure, are working on how to measure the interpretability of AI systems. What does interpretability even mean? How do we measure the bias? Bias is more than just demographic disparity. Those type of computational statistical bias is only one form of bias. There are other form of bias coming up from systemic bias that basically all the different knowledge and the biases in those knowledge baked in the society in the organizational assumptions find themselves into the AI system. So how to holistically measure any of these characteristics? How do we know is that the systems is resilient to the different vulnerabilities? It's private and the data doesn't leak. There's trade-off among all of these things. So there is a lot of work happening in this space, and for the full transparency, my kiddo is finishing his PhD and working in this space, and he just came back from an internship, and he said, AI evaluations is hard. I don't think we can ever fully be able to measure AI capabilities and limitations in a very wholesome way. So this is for our young researchers in the room, that areas that you need to work on this. The other thing is that risk tolerances may vary. What makes a system safe enough, private enough, secure enough, accurate enough, depends on the context of use. Example is face recognition. If you're using it to unlock our phone versus face recognition as if you travel to come to IJCB internationally, you know that our boarding card is being replaced by scanning our face. So using face recognition in the airport versus face recognition for law enforcement and kind of making it a determination that, yeah, this was the suspect in the crime scene. They all have different level of requirements for reliability, for accuracy, for interpretability. So there is no one size fits all, and all of these things has to be understood within the context of use. Our job at NIST is to provide and work with the community to build the scientific underpinning for AI measurement, methods and metrics on how to measure privacy, bias, interpretability, validity and reliability of AI systems. What we don't do is advise on the thresholds for pass or fail. But it's important to consider all of those things. And then the other two ones are goes more to organizational setting and less to the research setting, but risk needs to be prioritized. The resources for risk management, the resources for evaluations are limited. So how to make sure that we prioritize them in the right way to maximize the reliability, trustworthiness of AI systems. And then the last one that at least for NIST, they had put many different frameworks out for risk management, managing the risk of cybersecurity, managing the risk of privacy, and now we put another framework for managing the risk of AI. Every enterprise has a enterprise risk management, and so how to kind of integrate all of these things along the way. And these are all, there's technical angles to them because, for example, if you are trying to get a handle on AI security, both looking at how AI can be helpful for improving the security at the same time, understanding and mitigating the vulnerabilities of AI systems. Many of you in the room, I'm sure, had seen and looked at the papers with the Microsoft put out in 2019 Post-it note on a stop sign that confuses AI systems. And again, all of them through a socio-technical lens because context matters. So context matters, and again, socio-technical approach matters because along the way, what we were really trying to do is to promote two synergetic outcomes. We want the system to be reliable, functional, trustworthy. So there's those technical aspects that has to be addressed. At the same time, we want to address the practices of all the humans and organizations surrounding the system that determines how it actually impact or how the consequence of the systems manifests itself. Example of myself working in the AI space, I'm sorry, in the biometric space, I think we, at some point, we felt very comfortable on measuring false positive, false negatives. And Stephanie mentioned the quality and measuring the quality when we had an image. So anything about the process of capture and the human interactions with the environment to get the capture was not part of, at least, my research when I was working the fingerprint studies or any of these studies, because I was working with the images were captured, right? But those human interactions, and I think at that time they were using the word usability and maybe still using usability, you know, the affordance and how to make sure that actually the setup in a way that the user is actually looking in the camera to get their face images, or they're putting the right amount of pressure, or they place their fingerprint on the plate and right so they can get the best image. And they were all part of the equations of measurements and improving the quality of the capture and therefore the quality of the overall system. But at least for me, way back in 2006, 2007, it was sort of an aha moment that it's beyond the technical measures, and we need to also think about the surrounding environments and how the systems are being used. So with all of those things I mentioned, I told you that the first part of the AI RMF tried to come up with a shared understanding on unpacking this high-level concepts. And what you see here is what we came up with the community on characteristics of a trustworthy AI systems. So when we worked on this, there has been many other documents, I think a list of 150, 60 different characteristics. And again, with the work with the community, we distill it down to the 7 things that you see on the screen. Valid and reliable. You want your system work as expected, as it was intended for that during the time of the design. But beyond that, we want it to be safe to physical and psychological harms that can occur within the AI systems. Security and resilience. We talked about this, that AI systems has their own vulnerabilities there, from the data poisoning to the different type of inference attacks. AI systems can be evaded intentionally or unintentionally. So understanding all of those things becomes really important. Explainable and interpretable. There's a lot of talks about that the AI systems needs to explain how they come to the decisions, recommendations, prediction that they come into. We unpack the concepts of explainability and interpretability, one from explaining the models and the parameters, which is helpful, useful information for the debugging the systems, understanding the systems, mostly useful to the computer scientists, working with the models, building the models, from interpretability, which basically try to provide the context on why the system, the model made this decision or prediction. And that becomes important because in real settings, there are actually some laws in the book that for example, if a loan application is denied, there should be a explanation to the person that's the application is denied. And if AI systems is being used to make those determinations, it's important to provide some of the reasoning. So it's cool that now we are hearing in the news that OpenAI, for example, came up with a strawberry that can reason, and I think it's a very big deal. It's these advances in the technology to get the model to think and reason are fascinating. And from us at NIST, from the community that's focused on the measurement, the question becomes how we are testing them that we're doing the right thing. What are the right metrics, methods, methodologies for doing that testing? And that's really the bread and butter of the work that we do. And we love to hear more of you working on this or letting us know about your research results. Privacy enhancing, I'm sure you have read all of the papers that start coming out 2020, 2021, basically showing that the AI models, these big, large models, memorize the training data. Case in point, months ago, I don't know, 12, 13 months ago, it was showed that the large language model, if you keep, you prompt them to do the same thing or repeat the same word again and again, at some point they start blurting out the training data. So you can see that if the training data involves, in this in particular research that I mentioned, email communications, but if there are patient data, more sensitive data, there are huge privacy risks. There's a lot of interest across the NSF and other parts of the government to advance the privacy enhancing technologies. We ran a prize challenge with UK 2 years ago, and I think it's already on NSF website that we are trying to do more on advancing the field of privacy enhancing technologies. Bias and fairness, you have heard about this. Many of you are working on this space. I think the 2019 report that NIST put out that the demographic errors are not uniform across different demographics. I'm sorry, the accuracy errors, the accuracy is not uniform across the different demographics, was the empirical data to what a lot of people suspect or have experienced. So understanding this issue, and it's easy to quickly judge that, oh, it's the representations in the training data sets. It may very well be, but trying to have a deeper understanding of the different biases, from systemic bias to cognitive bias to computational and statistical bias, and being able to measure all of those things becomes really important. We put accountable and transparent as sort of vertical. I probably won't talk about those a lot in this presentations, but just say that that applies to the system, but also to the processes. So by transparency here, what we mean is clear documentations of the systems, how decisions were made, why they made. You're familiar with model cards and data sheets for data sets. And we also have seen that less and less are being reported in the model cards as the models are being released. So some of what are the things that we can do to sort of standardize those informations and the data that we want to see, that's needed to see in the model cards and data sheets for data sets, that can help with better understanding the systems and better assessing the systems. I just make one point here, sorry, going back to the slide. A lot of the work that we are doing, I mentioned a lot of evaluations, the models are built, and then we are trying to figure out the risk of privacy, vulnerability, the biases that they exist. One thing that would be very good for a lot of you guys, young researchers in the room, trying to figure out that how we can design and build models where these characteristics are actually built in, rather than as a bolt-on evaluations or policy after the systems are in use. I know a lot of researchers in many universities are working on this, and also companies. So trying to get to building the technology that does the right thing, rather than through the evaluations and the policies, trying to make them do the right thing or ban them if they're doing the wrong thing. So trying to move on again on AI RMF, with the another emphasis on the AI RMF is the shared responsibility for all of the different AI actors at any stage of the life cycle. And you see the life cycle that we put in AI RMF. There are roles and responsibilities. There are actions that must be taken to ensure that, for example, during the data collection and processing the data, that we have a good handle on the data in terms of the privacy, in terms of the bias, in terms of the representativeness. And now with the large language models, the issue of can we even use this data? During the development of the model, during the deployment of the model, there are roles and responsibility again for the different actors involved. So what we really need is a culture of responsible practice and use across all of these actors involved. and then have them communicate with each other through those transparency mechanisms. Right now, we are evaluating the systems without even knowing what type of training data has been used for training them. Would be very good to have those understanding, would be even great to be able to evaluate the training data for those. So there's a lot of emphasis on bringing more of the transparency around all of these things. And then another emphasis is that we need a continual monitoring. The risk management for AI systems is not something that you do at once and you say that, okay, I'm done because I have done the practices one time. I did evaluations, data drift happens, model drift happens, context of use can be changed. And it's important to keep a continual monitoring of the systems within use. So with all of those things, the second part of AI RMF, the core of AI RMF, provides a total of 74 recommendations categorized into high-level functions of map, govern, map, measure, and manage. I have slides on those, but I'll go quickly for each of them. Basically, the govern function is about setting up policy, procedure, institutional structures to make sure that societal values, organizational values, legal requirements, more importantly, have been thought of and have been incorporated into the systems. I'm sure you have heard a lot about human-centered AI. You have heard about value aligning and aligning with the values, and many of us, I would be one of those scratching my head and say, how am I going to design and build the systems on the value of a society that I don't even know about, and how to encode all of those things. So at least the govern function is trying to provide those type of recommendations. It's less on the technical side and more on the organizational recommendations to basically build that risk-aware culture. To ask ourselves as we are thinking about the design and development of the systems, that how it's going to be used, who is going to use it, what are the type of the impacts the systems is going to have, and these are really important questions. So the govern tries to provide that culture into an organization and entity, and more importantly, enable the teams that can have a say in risk management and encouraging them to have a say in the risk management of AI systems. The map functions is a very important set of recommendations on. I should have said that I just gave you some examples of the govern recommendations to give some ideas about what govern is. The map functions provides recommendations on basically understanding the context. It is really important to understand the context so we can start thinking about the risks that could materialize. Remember that example about use of the face recognition to unlock the phone, to go move through the screening lines of the airport to law enforcement. Different type of risks, different type of risk appetite is going to be in play for that. So, so the map functions try to basically help establishing the context, understanding what type of risk can be materialized, and does a lot of focus on this sort of a thinking process of the things that can happen, the risks that can and impacts that can be materialized, but also put a lot of emphasis on the diversity and participations. The person that we, as a designer and developer of the systems, will not have all of the knowledge about the type of uses of the systems, the type of risk that can materialize. So bringing that type of background and expertise becomes really important. The output of this function, the purpose of this functions is trying to inform whether to design, should we go ahead with the design of the systems, or developing it, or deploying it and using it. And if the answer is yes, how to do it in a responsible way. And here are some examples of the recommendations on the map functions. I can skip this one. I just want to say that the categories is the outcome-based recommendations in the AI RMF, but I'll mention that later too. Then we have activities that can help with the implementation of that categories and how we can do this. I think for the this audience, the measure functions will be most relatable, and this is really about setting up objective, repeatable, scalable test evaluation, verification, validation, or TEV as we call it. All that while you have a socio-technical lens, consider a human-centered approach and consider human AI interactions. It's important to note that we should do this. It's important to note that we measure to basically make sure that things are working as expected. But also understand the positive and negative impact of the technology of this particular model on the people. In AI RMF, we talk a lot about people, society, and planet, but all of those things. So, and this is the challenge right now, that majority of the approaches for measuring and evaluating machine learning and AI systems are rather system-centric. Or rather focusing on the understanding the limits and capabilities of the model. That's really important. That's still very difficult, but that's not enough, because just having an aggregate understanding of the false positive and false negative does not tell us about the behavior of the systems on edge cases, and tells us very little about the type of impact that can materialize for why the systems is in use. So that is, I will talk a little bit more about this. That is what we are right now focusing a lot on through some of the initiative that we have. So the managed functions basically gets the informations from the previous functions and try to come up with recommendations on how to mitigate or manage the risks. Important to know that sometimes you can prevent risks, sometimes you can mitigate risks, and there are cases that risk just, you can't do anything about it and it has to be accepted, and that gives you some understanding about how to use them. So AI RMF talks about all of these the prevention methods, the response, the accepting risks to transferring risks. I think what I can highlight on this slide is the incident response plans. This is something cybersecurity, in cybersecurity work has been done. There's a lot of talk about how to do that for AI, and through many of the different international work with OECD and others, we're trying to unpack the concept of incident versus accident versus hazard. So some of the bad things that can happen, but the level of impact, the level of type of mitigations measures or response measure would be different when something bad actually happened versus when there is a probability for that happen. So in a way, trying to say that we want to also have a focus on the risks that are here and now versus the risks that are hypothetical. All of them are important to consider, and it should be part of the broader risk management. We also put out a lot of practical, informative annexes, tools, documents out for helping with implementations of the AI RMF globally. We work on the crosswalk between AI RMF and other documents such as the EU AI Act, if you're following the AI regulations around the world, with a lot of AI governance that's coming out of the different countries such as Singapore, Japan, all of them on our website. You can look at that. The word on glossary, the word on terminology is something we think is really important. We can only have meaningful evaluations when we have a good understanding of what it is that we want to measure. And to have a good understanding of what it is that we want to measure, we have to be on the same understanding of the terms. I want to highlight the AI RMF playbook. This is a sort of, we think it's a very cool interactive tools that you can just go and get the information that you need from each of the functions based on your role, based on type of trustworthy characteristics. It's also the place that for each of those recommendations in AI RMF, we try to provide what are the different tools, algorithms, benchmarks, data out there. AI RMF says that have a plan to measure bias, and then they are in the playbook, we have some sort of a more information about what are the current tools for measuring bias. So this is all under constructions. AI RMF playbook is being updated every 6 months. For the whole framework, we put a revision cycle of 3 to 5 years. So love to see your involvement and collaborations there. This is sort of a for me, just check the time. Okay, do it quicker. Segue to what we are doing now. And the AI RMF, going back and talking about the flexible attribute, try to provide those high-level outcome-based recommendations or guidelines that you want to get, but it leaves the specificities and sort of the descriptive method to be handled during the profiles. And the profiles of AI RMF, really, we think of it as instantiation of AI RMF for particular use case. The use case can be just an applications into a system, or it can, an applications within an organizations, or it can be application across a kind of a broader entity of the society, at the city level, at state level, all the way to the different disciplines, risk management of AI systems within the context of the financial sector, health sector, criminal justice. I know the National Academy suggested a profile of AI RMF for face recognition that I know that my colleagues at NIST are working, thinking about this, and I hope to be able to collaborate and contribute to that work, all the way to profile of AI RMF for cross-sector, and that is large language models profile. That's what we use in the text of the AI RMF when we released AI RMF, and then months later, we got a task from the Congress to actually, executive order, White House to actually do that. Quickly on this is that AI RMF, as much as work that we did, there was a lot more to be done. Some of the items, this was released at the time of the release of AI RMF, from alignment with international standards to expanding the evaluations to better understanding of the human factors and human AI teaming in the context of AI, better understanding of the trade-offs between the trustworthiness characteristics. These are all research and some technical / policy areas that we identified for us and the whole community to work towards them. And as we were working on all of those things, AI RMF becomes sort of our North Star, grounding all of the work, all the future work that we're doing within the AI RMF, advancing the measurement science for AI becomes the core activity after the release of the AI RMF. How do we better measure, evaluate AI systems, their capabilities, limitations, impact, risks, and everybody answers, at least in the circles of government that I talk to, needs answers to these questions now, but we really don't have the scientific underpinning for how to do AI evaluations in a scientific, repeatable, reproducible way. And we really need to build that scientific foundations, the building blocks for developing guidelines and standards. And the way we do it, many of you may know, is that we run evaluations. These are called research evaluations that try to benchmark the state of the technology today, but also it's a sort of a trial ground for us with the community to revise and devise metrics and methodologies. So we're creating test environments and conducting evaluations. I'll be talking a little bit about this. So as we were focusing on those things, implementing the items on the roadmap, we got a executive order end of October that tasks many different agencies to work on many different areas, and in particular asks NIST to ask is a soft word, directs NIST, task NIST to develop evaluations, red teaming, safety and cybersecurity guidelines. It asks us to facilitate development of consensus-based standards. It asks us to provide a testing environment for evaluation of AI systems. And true to NIST nature, we do all of that in a open, transparent, collaborative manner, and leave it out for the community to use. So this is the sort of the timeline and the tasks that we had to do. You will see that there is a lot of tasks there. I'm just happy and pleased to say that everything on July 26th was delivered. And I'll be talking a little bit more about each of them, and I try to go quickly, but this is really our recent work and the areas that we love to get you guys involved. So one of the things that we mentioned in AI RMF, a possibility of doing a cross-sectoral profile of AI for, we mentioned large language model there, but the task that we got was do a profile for use of AI RMF for managing the risk of generative AI. And what we did is, well, even before the executive order, we had put a group of public volunteer together, 2,500 public volunteer to help us to better understand the risk of generative AI. That public working group ran from end of June 2023 until November 2023, and gives us the basis for this document. And of course, the consultation that we do with the community and all of the comments on our website for you to look at. But what this document does, it lays out 12 risks that either new and novel, unique to generative AI, or exacerbated by generative AI. I let you guys read this. A lot of these things should come very sort of self-explanatory to you. Generative AI can lower the barrier for accessing to privileged or protected data that can be used to launch chemical, biological, nuclear attacks to systems. It can also lower the barrier for launching cybersecurity attacks. So information security, information integrity, issues of the privacy, and all are exacerbated by generative AI. Confabulation, or as many of the documents talk about, hallucinations, that is because of the kind of this sort of a back propagations, right? They just put out the next token without having a better understanding of the whole context. And the environmental impact of the AI. So AI can do a lot of really good stuff, but also it's the electricity, water being used to train the models are a concern. And now we are seeing that war is getting into the inference part, particularly as models are being built to decide with OpenAI strongly to be able to, apologies for my dog, sorry, to reason. These are the 12 risks, and then it gets into trying to address each of these risks and the things that can be done for managing these risks. It also talks about that there is different dimensions of variations for these risks. It depends on the scope, stages of the AI lifecycle, source of the risk, time scale. All of these things becomes important on managing the risk of the generative AI. This is a work in progress. We're going to do a lot of more work on this, on better fleshing out each of those risks, but also coming up with measurement methods for each of those risks. And we love for all of you to be in touch with us. We were also asked to do a landscape survey of the synthetic content and the harms and risk of synthetic content, particularly as it's related to CSAM and NCII, child abuse and obscene images without consent. And what we did in this report was actually what we did with this report is sort of trying to bring the whole provide a taxonomy of digital content transparency, that there's a lot of talk about provenance data tracking, digital watermarking, metadata recording. It talks about those methods. It talks about the limitations of those methods. There is a sections talking about the methods for synthetic content detection. As part of the digital content transparency, we think that not all of the solutions are technical, and educations and regulatory market-based approaches plays a big role, but our report does not address that one.
So Elham,
yeah.
can you hear me?
Yes.
I think in terms of time, if you can
Wrap
come
it
to
up.
some conclusions, even though that was really interesting,
Sorry.
that last slide too. So I know
let
that
me
the
just
audience
say,
wants to hear more.
Yep, I just want to talk about two initiatives that we have. One is the ARIA, assessing risk and impact of AI systems, that I think I've mentioned that a lot during my presentations, that a lot of the evaluations today just look at to see if the model output is correct, and we're trying to expand it to see what are the risks that can be that can arise, what are the impacts of the systems, how often they happen. This is happening right now. It's an umbrella programs. You can look at our websites, and we love to see participation in these tests. And also we are evaluating the under the generative AI technologies evaluations right now. We are running the 2 tracks of red teaming, blue teaming of the synthetic content generators. So we have a track for text-to-text generation and assessing how good and how reasonable the text generation would look like, and another track of getting a text and kind of classified as AI generated or human generated. And the text-to-image track is coming up soon. We also have a symposium on coming up on September 24, talk about all of these things. But if I can just take a minute on the closing talk and say that we all agree that AI is the most transformative technology of our time, but it also needs its own safeguards. And our job as the technical community is coming that not only advancing the technology, but also building the safeguards so that do the risk management to unlock innovations, to harness the power of AI for good, for use by all of them. And at the beginning, I said, when it comes to AI, there is a lot less we know that we should. And we can change that. We can change that by engaging and intensifying our efforts to advance our scientific understanding of these models. We don't know how these models work. We need to do more to understand them. We need to understand and address the AI impacts on people, society, and planet. We need to do more research on measuring and mitigating risks, including safety, security, privacy, reliability. We should also try to get AI, advanced AI as a scientific discovery tool in other disciplines to solve major problems of our time, from climate change to healthcare to education and more. We must make sure that we invite and bring and value a diverse set of inputs and thoughts and backgrounds and perspectives. And we also need to nurture international collaborations. The concepts of, for example, privacy can have different meaning at the different part of the world. And if we want a technology that's usable across, we need to have a better understanding of all of these nuances. Bottom line is that we want technology that work accurately, reliably, that's easy to do the right thing, difficult to do the wrong thing, and easy to recover if something unintentionally happened. And that's where I think the bulk of the research should go. That's where we can work together. That's where we can build a scientific foundation to address all of those. I start by saying that when it comes to AI, there is a lot less that we know that we should. And I think the operative word there is we. So let's work together, collaborate together to solve this problem. Thank you. Sorry if I ran over time.
No, thank you very much. We'll take a question or two. Just we're very lucky to have Elham. Any questions from the room? I had a question. I really appreciated your suggestion, to the audience, particularly the young people who are looking for interesting research problems, about the question of, rather than bolting on things at the end of what we want these systems to do, but to create systems that, inherently put in the safeties and safeguards that we would like to have. And, but there's a kind of a problem, as researchers, which is, some of the things relate to, the demographics and bias kinds of questions, as well as the edge cases you talk to, are all very data driven, and data is really, really difficult to gather. And in fact, now more and more, the collection of the data for these purposes of training, a lot more scrutiny is being put on that. I just wonder, from kind of your wealth of experience, I'm sure you've heard this, like where do you see the future going to sort of enable doing the good work that we want to do, but do it in a responsible way?
You're absolutely right. And I think I also mentioned that, I personally think that evaluations should also include evaluations of the training data, which we don't have access to. It's a difficult thing. It is a challenge, and we need to put more of these capabilities and abilities out. Right now we don't even have a sort of, if somebody is again, example of my kiddo is doing a paper and building a systems and want to test that, they go to some of these open benchmarks and try to do that, or write something of its own and try to test the system. So the more of those open benchmarks, the more of those repository of the metrics that we can have, and the more we get people to use the same thing and report on if they work or not, the better we get at the things that work, and also increasing our knowledge of the gaps that are there, including the gap that you identified. So I think what we are trying to do is sort of build those repository of open source tests. We were going to run our own tests. If you're familiar with the Trek, every time that we do a Trek, we put all of the data out and all of the informations out. So with the ARIO and GenAI, we're trying to do the same thing. And as the community build that type of infrastructure and banks and repository of the data and methods, and empirical data of what worked or not. So that is what, at least what we're trying to do, but love to hear thoughts from the community, and we are here to learn from the community and try out many of these methods.
Yes, thank you. Thank you. Any other questions? Got one? Oh, okay. Yeah, go for it.
Wanted to kind of ask you your thoughts on, this larger AI framework or risk framework that you shared with us. How does it apply to face recognition in particular? Because there is so much of focus on that technology that this community, our biometric community, has a lot to contribute to.
Yeah.
And I am seeing there's a lot of caution, red flags coming out of Europe in this regard. So what are our thoughts or NIST thoughts in this space? Thank you.
Thank you very much. And right, and National Academy in the US ran a study on use of face recognition. And by the way, we are also administrating a presidential advisory board, NIAC, National AI Advisory Committee. And they do have, by statute, there is a subcommittee on law enforcement, and they put a report out for face recognition. So, and the National Academy also suggested on doing a sort of profile of AI RMF for face recognition. I will tell you that I don't think banning of any technology is the right way to do. And what we do with that, we just close the knowledge sharing, innovations that can happen. Instead, what we need to do is thinking about the right guardrails, safeguards, and provide the space for the innovations to happen and the technology to improve our needs in the society. There has been talks with my colleagues at NIST that we work on a profile of AI RMF for face recognition. We can even make it a more community activity, but the ingredients are all there. So I try to show you some of the examples of the different recommendations in the different functions. There are a total of 19 categories and 72 subcategories. So each category divides into subcategory. And what we need to do is look at each of those subcategories and think about how it relates to face recognition. Some of them is, going through the trustworthy characteristics that I showed on the slide and figure out what each of these things means for face recognition. What are the tests available today for testing for those? Bottom line is, again, if we can have a knowledge about the system's functionality and trustworthiness, then we can make decisions, the right decisions on the risk management, that what applications face recognition can be helpful, useful for, what are the risks and how to respond to risks. So we better do that work rather than having a one brush stroke of, no, we are not going to use the technology.
One more question.
So thank you so much for the wonderful insights you shared with us. You raised an important point, which is the risk variability across applications. I was wondering, in the case of face recognition, what is the privacy risk difference between law enforcement applications and, for example, if you want to unlock your phone? Because as a researcher in this area, when we build and try to protect the privacy and security of biometric recognition systems, we tend to do it regardless of the application.
Yeah.
Thank you so much.
Yeah, thank you. Right. So the privacy is one of those examples, but I was trying to say that, the requirements and the threshold can be different, and the level of accuracy and the, every time that you set your threshold of your biometric systems, you make a trade-off between false negative and false positive. So the two extreme applications that I said, unlocking our phone, I want a lower false negative because I get annoyed if the system denies me over and over again. But for a law enforcement, you want a very lower false positive because we want to be mindful about locking up the wrong people. In terms of those trade-offs, I think first and foremost, there are legal requirements that needs to be addressed. So we tried to put a document out, and I don't think it became public, but it, well, another entity, I think Equal AI last week or this week, put a document out about the laws that are on the book that apply to the AI system. So when it comes to the privacy, of course, we don't have a federal privacy laws, but there are state laws. So for any of those applications, if there are laws, they had to be abided by those. Then after that, it becomes, like any good software engineers, there is a requirement solicitations that needs to be done. It also gets to the application. Is it one-to-one or one-to-many? The one-to-one applications will have probably lower risks of blurting out the training data. So all of those things becomes the considerations that you need to do as part of the design of your system. And I start by legal requirements. Of course, we all have to abide the laws. So.
Well, I would like the audience to join me in thanking you, Elham, for being our keynote this morning. Fantastic talk. Thanks, Elham.
Thanks for having me.
All right, now we move into the oral sessions and take action on those